Wiring a Winning Software Organization with Gene Kim.
The Azure DevOps Podcast is a show for developers and DevOps professionals shipping software using Microsoft technologies. Each show brings you hard-hitting interviews with industry experts, innovating better methods, and sharing success stories. Listen on to learn how to increase quality, ship quickly, and operate well. And now your host, Jeffrey Palermo.
Welcome to the show. I'm Jeffrey Palermo, your host for helping you and your teams move fast and deliver quality and to run your software with confidence in Azure, all while using everything that the .NET ecosystem has to offer. The podcast is sponsored by ClearMeasure, which is a full-service software architecture and engineering firm that serves companies that are building mission-critical software systems. Quick announcement, we are in the second year of my software architect forums. You can sign up for the next session at the link in the show notes or go to clearmeasure.com for that. And we've also launched a new executive software leadership forum for technical executives who oversee software engineering groups, from CTOs, VP of engineering, any manager, executive level that is tasked for overseeing software groups. We understand there's tons of learning opportunities for individual programmers. You can just go online and watch videos. But for people who are running organizations, either at the architect level or at the executive level, it's a little bit harder. There's not as many opportunities. And so these are peer groups. We're getting people together who face similar challenges and talk about it. So I facilitate, and I have each month a different topic, and we all rally around that topic and share success stories, and ask and answer questions, and help each other get better. So you can go to clearmeasure.com and sign up for either one of those, depending on what your role is. And for those of you who are looking for Programming with Palermo, my video podcast, you can just search for it in any of the directories and you'll be able to find it. My guest today on the show is Gene Kim. Gene has been studying high-performing technology organizations since 1999. He was the founder and CTO of Tripwire, Inc., which for 13 years, which is an enterprise security software company. His books have sold over 1 million copies. He's a Wall Street Journal bestselling author, most recently co-authored Wiring the Winning Organization, as well as another book, The Phoenix Project, another book, The DevOps Handbook, and the Shingo Publication Award-winning Accelerate book. And since 2014, he's been the organizer and program chair of DevOps Enterprise Summit, studying the technology transformations of large, complex organizations, now called the Enterprise Technology Leadership Summit. And you can find his website at itrevolution.com. Gene, welcome to the podcast. How are you, sir?
Oh, Jeffrey, I'm doing great. And thank you for having me on. And congratulations on all the amazing podcasts that you recorded. And I'm delighted to join the pantheon of people that you've had on your show.
Oh, my pleasure. I'm excited to have you on because in myself, in my circle, all of my engineers at work, we've all read your books and we've all benefited from that. And so I want every listener of this podcast just to understand, if you haven't, I'm talking to the listener now, if you haven't at least read the Phoenix Project, the DevOps Handbook, get started. They're so good. They're quick reads. And now I'm giving you the commercial, but that's what I think. They're so easy to read. By the way, the material is just presented in story format, and that's been a huge help. So you've helped a ton of people in the industry just by your writing, and I'm glad that you released another book in 23 to keep that going.
Oh, right on. Yeah, in fact, can I tell you a little bit about maybe why, why another book, which is
Please do.
I love that phrase. I hate writing, but I love having written. Was that Mark Twain who said that?
Oh,
it was came out of a sense of just genuine desire to understand something better. Or actually, maybe I should just rewind just a little bit. So I've been studying high-performing technology organizations for 25 years, and one of the unexpected things that happened was that it took me into the middle of the DevOps movement. So that was in 2010. And so the Phoenix Project is really, it's been amazing to see how that book has really turned into kind of like a rallying banner of like, how do you find the kindred spirits who are just really sick and tired of doing software the bad old ways, right? There's nothing wrong with the old ways, but if it's old and bad, right, it's particularly excruciating. And one of the neat things that happened out of that was then working on a project called the State of DevOps Research. So that was with Dr. Nicole Forsgren and Jess Humble. And that was this amazing study that spanned 6 years and 36,000 respondents. And the goal was to really understand, what does high performance look like? And what are the behaviors, norms, technical practices that predict high performance? And so it was just amazing just to be able to generate some actual quantifiable data, right? Just like how the cross-population instrument is what the medical community used to establish the link between smoking and early morbidity and mortality. So we use the same instrument to be able to say, oh, look, hey, these high performers, they deploy more frequently, they have far better outcomes, they have better security, they're better at achieving business goals. And there's like really three things that predict performance. One was the technical practices like CI/CD, fast feedback. The other one was architectural practices, right? The mark of a great architect is to what degree can architecture enable independence of action, right? And then the third one is cultural norms. I think the best verbalization of that was around the Western organizational typology model. Pathological versus bureaucratic versus generative. There's still this lingering mystery, which was, in the DevOps community, we often, cite the lean principles. We cite resilience engineering, and so it sort of leaves us very uncomfortable questions like, what really is in common between Agile, DevOps, Lean, safety culture, and so forth. And so the book really came out of this decade-long collaboration with a mentor of mine, Dr. Stephen Spear, from the MIT Sloan School of Business, who wrote the most widely downloaded Harvard Business Review article of all time called Decoding the DNA of the Toyota Production System. Right? And so that was actually based on his doctoral dissertation that he did at the Harvard Business School, where he worked on the plant floor of a tier 1 Toyota supplier for 6 months. And so it was just, we spent 3 years, really starting to really ask the question, like, what really is in common between all these methodologies and frameworks and so forth. And our conclusion was that they are all incomplete expressions of a far greater, but also simpler whole. And the thesis really was that when you look at any of these frameworks, or if you look at Conway's Law, if you look at team topologies, really there's really only 3 mechanisms that work, and we call them slowification, simplification, and amplification. And really, you can derive them all just by asking, the question like, describe the conditions where it is the most difficult to solve problems. One, you make it really fast-paced. You make it really, you take away any ability to undo or redo. You make every mistake, even no matter how small it is, cascade out and cause global catastrophic failures, right? Which makes learning impossible because you can't iterate, and you make no time to sharpen the saw, right? And so really, when you sort of explore the opposite end of those conditions, it means that you can do your most dangerous consequential work not in production, but instead do them in planning and practice. You make time to improve daily work, and maybe it's even more important than daily work itself. And you change the nature of the actual problems themselves. That you take, these kind of highly coupled problems where one mistake in one place can cause mistakes in distant parts of the system. You separate them out and partition them, so that not only does it sort of contain the blast radius, but it enables independence of action. So that's people can actually work independently of each other. And then there's actually a similar one that's for parallel processes. There's one for sequential processes, which is that you linearize them so that, again, you can, CI/CD is a great example, that you can decouple the work of developers versus the security engineers versus the ops engineers, and enable also independence of action. And then the last one is amplification. Make it so that even small signals of failure, the weakest signals of failure, can be amplified so that they can be acted upon to either prevent, or detect and correct. And so just the notion that, really those 3 kind of mechanisms that really show up in like everywhere, not just in software architecture and software design and operations, but also, in lean safety culture and so forth. Anyway, how am I doing so far?
Yeah. Well, that's a really great rundown of the new book. And I'll have some questions about those three specifically. Before we go into that, can we back up a little bit? Even before you started writing, what are the moments in your career that are kind of formative that led you to what you're doing today?
Yeah, great question. So, you know, actually, my first book was called The DevOps Handbook. It came out in 2004, and it was all about creating world-class security and operations, in 4 practical steps in ITIL, right? And so, some people sort of laugh at ITIL these days, but I mean, back then it was a revelation, right? It's like
Mm-hmm.
many ops organizations. There was no notion of what ticketing was for, and how do you use ticketing for the resolution, incident resolution processes.
Mm-hmm.
But I think kind of the big insight was that those organizations that had the best security were the ones that had the best working relationship with operations, and vice versa, right? That there were common practices and processes that they need to integrate into, and so that was actually a huge insight in terms of kind of this, for me, starting the journey of studying high performing organizations. And
Mm-hmm.
then by the time you can't get very far in that discussion before you realize that there's some other missing stakeholder called development, right? Who also has to be a part of that collaboration. And so by the time that revelation came, that was around 2005, 2006. And I think just seeing kind of the failures that would happen when development is working in isolation, and the first time the ops people see it is a week before the deployment, and just seeing the mayhem and catastrophes that would result. I mean,
Mm-hmm.
that was, I think, the common experience of almost everyone who found themselves in the DevOps movement. And so when I attended my first DevOps days in 2010, I mean, it was just my feeling was, oh my gosh, I found my tribe, right? And
Right.
that became a group of people that started working very heavily with, and so much informed. The Phoenix project was, I think, already probably 10 years in, right? And so it came out in 2013. But so much of that was informed by those amazing things happening kind of in those early days of companies large and small, trying to
Mm-hmm.
figure out a better way to do things.
Right.
How am I doing?
You programmed, for quite a bit before then,
Yeah.
but 2004 or you've been thinking about how to make programming teams better for a really long time, right?
Yeah,
But
although back then it was all about like the poor ops people and the poor
well,
security
yeah,
people,
yeah.
right? Yeah, no, for sure.
Well, how to do software better. You're right. If
Yeah.
ops and developer they're not even talking together, things aren't going to go
Yeah.
right. But just building software, putting it in the hands of the user, that whole process, it's got to be done well. And there's all kinds of ways for it to be chaotic and broken.
Yes.
And you've been thinking about that for a long time. Um, and a lot's happened in that time frame. The from 2001 on, the agile movement, and then cloud became a big thing, and then DevOps basically filled in and said, "I think there's some gaps here. Yeah, agile this and cloud that, but hey, wait a minute, there's some stuff that's missing." And so in the 3 points, which I think are brilliant: solidification, simplification, amplification. Is any of your thought process a replacement of some of the things, or is it a categorization of some of the practices that the industry's kind of figured out over these movements?
Yeah, I think it's definitely the second, right? It's basically sort of beyond the industry kind of treatment of like physical manufacturing and lean and software development and with a Scrum, XP, and so forth. Right, really, what are the underlying mechanisms that are in common, right? And so, but I'll tell you, like, what some of the big aha moments that came out of working with Dr. Steven Spear was that maybe the question is like why why is it even more necessary now more than ever to look at these principles and practices. And for me, one of the big just genuine gobsmacking moments was looking at healthcare organizations. So like one of the things that I'm really
Hmm.
proud of in the Wiring the Winning organization book is that there's 24 case studies of which 20% are technology related, only 20%. The one
Mm,
that
okay.
some of them are aviation, some of them is like space flight, some of it's but the largest category of case studies are in healthcare, specifically emergency departments. And so like there's really two big revelations. One is that life was much simpler when we didn't have very many functional specialties. And so in the book, we introduce this construct saying that's really 3 layers of work. Layer 1 is like the work and object in front of us. It could be the code that we're working on, or the binary that's running in production, or the patient. Layer 2 is the tools and technologies. So that's the IDE that we're editing code in, or it could be the Kubernetes platform, or it could be the MRI machine, the CAT scanner, the blood tracers. And layer 3 is really about the social circuitry, the organizational wiring. And what's astonishing is that if you take a look at like any sort of DevOps case study, in general, right, the only thing that changed is in layer 3, right? In other words, the same people, same equipment, same floor space, same managers, right? The only thing that changes is the software architecture. It could be a little bit of automation, right? But in general, right, whether you're talking about the NUMMI plant in Fremont, California, or the safety culture at Alcoa, right? What's in common is that the difference maker is in layer 3, right? So it says, and in our world, right, layer 3 is the software architecture. It's how we structure teams, and the team of teams is who's allowed to talk to who about what and when, right? So the aha moment. So emergency departments in healthcare are just notorious for just like how accident prone they are, right? No one has what they need when they need it, right? And the outcomes are that there's accidents and injuries and all sorts of terrible things. But it wasn't always that way. That in the 1950s, there was actually a far safer system. And the conjecture is that it's only because there was it was a far simpler system. You had basically at layer 1, you had doctors and nurses. You had very little technology. You had X-ray machines, which aren't very high tempo. So you could get away with a very simple layer 3 wiring. So you fast forward 70 years and you take a look at the explosion of functional specialties. You have like 20 different functional specialties just among clinicians. You have nurses, supply chain, pharmacy, right? Then you have technology at layer 2, right? It's not just X-ray machines, it's MRIs and CAT scanners, and you have like EMR systems and so forth. So just consider like how much more complicated and sophisticated the layer 3 wiring has to be, right? And so kind of the big takeaway for me was that, as you increase the number of functional specialties, you have to have an ever more sophisticated layer 3 organizational wiring. And done poorly, you end up with, no one has independence of action. You have, small errors creating catastrophic, consequences. For me, it just shows like in our world, like just look at how many more functional specialties we have. It's not just .NET and Java. Now it's containers, it's Kubernetes, it's Gen AI, prompt engineering, ML ops. It's just like consider like as an architect and as a leader, right? How much more careful we need to be, right, about finding kind of like who should talk to who when, right? And even the way we talk about like Conway's Law and team topologies, I think it just shows that really, our attention should be focused on layer 3. How am I doing here, Jeffrey?
That's a fascinating way to look at it. Do you find, is there any rule of thumb emerging where one should attempt to have fewer functional specialties or not? Or is that just a recognition of the environment?
Yeah. Oh, what a great question. In fact, I guess conjecture number 1 is we should have fewer functional specialties. But I now self-identify as a developer, whereas like for decades, my real love was infrastructure and operations. But now as a developer who just wants to ship my feature that solves my problem, there's all these things I don't want to deal with. Like, for example, anything outside of my application, like connecting to databases and secrets management and CI/CD pipelines and YAML files and cloud costs and PubSub Kafka queues, right? like literally, I don't care. I mean, I know they're important, but it is, the feelings that those things evoke in me is like frustration, maybe some anger, right? It's like, why do these are things that are probably important. I know are important, especially security, but they're like not what I woke up in the morning wanting to do, right?
Yeah. You want it to be taken care of, but you want somebody else to take care of it. So then the decision is, okay, can I get something that's commoditized so it's taken care of, versus hire yet another person in my team who is that functional specialist?
Oh, totally. In fact, I mean, just a recent story. I was trying to do some image to text stuff on
Yeah,
on an LLM, and I didn't want to do it on my laptop. And so I went into Google Cloud and was then trying to figure out was then prompted with 24 different GPUs, and
sure.
I don't know. I'm not sure how much I care. Right?
Yeah,
I do
yeah.
care about cost. 2 hours later, I'm like, screw it. I couldn't get the drivers working. I couldn't get
Oh,
the
no.
load monitors working. And at this point, how awesome would it be to just have a friend, or better yet, a person whose job it is to sort of create these VMs that just have it working already, right?
Yeah,
And I think this
right.
is where these days, this is where large organizations, I think, have an advantage over small organizations, because when you're sufficiently small or a solo developer, right, you have to do it all,
Hmm.
right? And so I think one of the affordances that larger software organizations get to have is they can bring to bear these functional specialties. A friend of mine was just talking about how um, this person probably for the last 15 years have written too many grants star to user star, right? They're just
Okay.
someday promising to fix it, right? But how great would it be just to have a database functional specialist that could just help, do it right? Does that resonate with
Yeah,
any of your experiences?
it does. What it makes me think of is the architectural choices and this concept of latency versus low latency in people. And the early agile movement said anybody that needs to do work, put them in the same team, co-located, even grab a customer and have everybody there. But with a growing number of functional specialties, whether they're at a vendor, whether it's, Azure takes care of it, but then we need like some Azure specialist for the hard stuff. Uh,
Yeah,
we're not going to, and especially in the last 5 years with tons of remote people and whatnot, fewer and fewer organizations have everybody in the room, every specialist all the time. And so then it seems to me, correct me if I'm wrong, is the architectural choices can either put a communication boundary outside the nucleus of the team on something that has to be done all the time. So you have like high chatter, or orchestrate the boundaries so that when we have to go outside the team to that functional specialist, it's a less chatty communication pipeway, so that we're not waiting or we're not blocked so many times because we had to have some communication outside the team
absolutely.
nucleus. Is that the
Absolutely. In
concept you're
fact,
talking?
I think let's take it even one step further. Yeah, and the best low chatter one is like no chatter. Like, here's your API,
Mm-hmm.
right? And if you use the API correctly, right, there's no ticket, there's no request, right? It's like you get to use it, on demand. And just imagine, for the developer, for the consumer, it is, enables focus, flow, and even joy, right? As opposed to pestering someone for 8 weeks to try to get something that you need to get your stuff done, right? Which is like kind of a frustrating place to be, and that's really the premise of the Unicorn Project. But I'll give you an example that sort of came to mind. I was laughing as you were asking the question. I think one of the I think it was the Thanksgiving holiday a couple years ago.
Okay.
One of the it was a illuminating. I decided to spend the Thanksgiving weekend or week learning about Java logging. We
Okay.
were talking beforehand, right? That my favorite programming language is Clojure, and it runs on the JVM. But
Yep.
I was never a Java programmer, right? So I found all of Java logging to be just
Log
a
for J.
huge
Yeah.
mystery, right? Log4j,
Yeah.
SL4j, utils, Java util logging, right? Like,
Yeah.
don't know, don't care. But at a certain point, you just at some point need to understand how to get it working right. And
Right.
so I spent 4 days learning a lot of stuff that I didn't really care that much about, but I did care about getting logging working.
Mm-hmm.
And it turns out that it was a couple months before Log4j, the big exploit. But really, to me, it was ridiculous that I was learning this on my own. I just wish, like, my cloud vendor or somebody just said, here is how, if you want your output to show up here, here's all
Mm-hmm.
you have to do to copy it in, right? And just have enough understanding of, like,
Yeah.
if it's not showing up there, what could be going wrong. Anyway, so consider like if I could wave a magic wand, I would have been a part of an organization where there was just a sample app I could just copy,
Right.
just exactly what to write, and then I click on this link, and that's where I'll find my log output. Like,
Mm-hmm.
I think that is an example of uh, enabling services that create independence of action, so that people can just focus on what they want to focus on, right, without having to do a lot of communication, coordination, and cajoling, and politicking, and escalating, to get what they need.
Many thanks to our podcast sponsor, ClearMeasure. ClearMeasure is a software architecture company that empowers clients' development teams to be self-sufficient, moving fast, delivering quality, and running their systems with confidence. Whether starting a new project or developing new technologies or techniques, ClearMeasure sets up your team to deliver world-class results. Learn more at www.clearmeasure.com. ClearMeasure, empowering software delivery. ClearMeasure is also happy to be a sponsor of the video podcast, Programming with Palermo. Watch, learn, and program alongside Chief Architect Jeffrey Palermo. Videos are added weekly and available on syndicated locations supporting video podcast or by visiting palermo.network. Tune in today.
It's interesting as you say that. You're right. Simplification. The big tool vendors, and Microsoft being one of them, and open source authors, it's almost like there's a force to make it the next level more flexible or add the next new capability with a configuration switch. And, there's always somebody off to the side saying, well, wait a minute, it doesn't support this. You need to add this other. And so you end up with a hugely configurable tool that could do a bunch of stuff, only if you know all the switches.
Right.
And for the 80% use case, the prominence of the 80% use case is demoted to the same level as all these tiny little specific features, instead of 80% use case. And then, by the way, if you want to do the other stuff, okay, you can opt out of the easy button, and now you can have access to all the switches.
Right. With like no fuss. In fact, can I share with you kind of like the kind of the pathological case of like what happens when you make it impossible, like you apply the opposite principle to everything.
Yeah, please.
So a group of friends and I, we wrote a position paper called the Checkbox Project. It was sort of a kind of a riff off of the Phoenix Project. But imagine you're part of a mobile telco where one of the top 5 initiatives is to present a checkbox to your 20 million users so they can opt into a $5 a month service to get email or watch movies or so forth. The problem is that you have to get this done. You have to transit across 40 different teams, across 4 different customer channels, right? So digital, store, support, etc. It requires CEO -1 level support, daily war room meetings, $28 million, 1 year. And the bad part is that most people give it a 20% chance of succeeding. Because why? Because the last 3 times they tried it, didn't work, failed, right? And so here's an example where, the checkbox, right, to dramatically oversimplify, is not a very technically challenging problem at layers 1 or layer 2. What this is that this is all, the difficulty is all around communication and coordination and trying to get all these pieces to work towards a common goal.
Mm-hmm.
And what it means, the term I've used is, independence of action. Can teams work independently to get done what they need to get done without having to deal with 35 different outside dependencies where you need their cooperation and consent to get things done, right? And so I think that'll be very familiar to architects, because it, that's definitely a goal that we want to achieve. But I think the countermeasures to that are things like exactly what we're talking about, where it's about enabling self-service, it's about enabling platforms, so that these functional specialists can enable their teams to get done what they need to get done, that they don't need to worry about what it is, right? And that allows them to focus on radically different areas of concern, right? But achieve the most important goals of the organization. How am I doing?
Yeah, that's good. I want to get your opinion on the kind of trend that I think started maybe in the 80s or 90s with the microcomputer, and then having a computer on every desk. And as they got more complicated, all the techie people formed a new department. We call it the IT department, right? But the IT department hasn't been around in business for, for 100 years. It's relatively, a new phenomenon. And then we have all these problems with separation because all the IT people are somehow in a different department, but we're trying to serve the department that they used to be in decades ago. So just as you project into the future, is the concept of the IT department going to be like a period of time in history where or is it a good idea? Is the concept of an IT department a good idea or a bad idea, or should it just be, everybody deployed to the operational departments and just be serving them directly?
What a great question. Of course, the answer is it depends, right? But the most important thing is, what does it depend upon? And I think we actually put together a kind of a firm point of view on that. And I think it's best answered in this kind of this metaphor about two people moving a couch. So can I give you like a 2.5 minute performance art about so let's imagine two people moving a couch. Let's call them Steve and Gene. And so you might laugh at this activity because it's all brawn work. There's no brain work needed, right? But it turns out like Steve and Gene actually have to solve a bunch of non-obvious problems, like where exactly is the center of gravity? To get through a narrow doorway, around which axis do they rotate? To get down a narrow winding set of stairs, who goes first? And should they face forward or backwards? And so you don't need a lot of consultants or focus groups. Just by picking up the couch, trial and error, experimentation, but most importantly, coordination and communication, right? We can have some confidence that Steve and Gene will, achieve their goal. But there's all these things that we can do as leaders to make their work more difficult, right? So we can turn off all the lights, right? Which means the work becomes more dangerous, will take longer, they might damage the couch, the rooms, or maybe even themselves. But another dimension that we can make the work more difficult is we introduce a lot of background noise, like loud music, a siren. Or we can even introduce an intermediary that prevents Steve and Gene from talking directly to each other, like making them go through, JIRA tickets and work orders and maybe account managers and lawyers, right? And so under those conditions, right, we can quickly imagine a scenario where like Steve and Gene will not achieve the goal, right? Because their need to what needs to be communicated so far outstrips the bandwidth that's been afforded to them. And I think that's actually what caused the DevOps moment, right? Where like there's no amount of fields in the ticketing system that can accommodate just how much information needs to be communicated and shared between the Dev and Ops group, right? And so, and I think that's really wasn't common between the healthcare emergency departments, DevOps, security and ops. For me, 20 years ago, and so it just really, I think any architect will immediately say that this is really a metaphor for two critical concepts. One is coherence, right? To what degree are Steve and Gene able to work as a coherent whole, right? And when you put an intermediary in, they're not a whole, right? They are isolated in their own silos. And the other one is coupling. And I just loved how Kent Beck addressed this in the interview that you did with him, right? Is that, Steve and Gene are coupled together through the couch. What affects Steve affects Gene and vice versa. And so in the platform teams, right, there's sometimes when we want very close coupling, right? With Dev and Ops, we need them coupled together because it's hard to do good work, without it. But what we do in software architecture is we try to decouple things because when you have 3,000 people all coupled together, no one can get what they need to get done. It's like the checkbox project, right? You need communication, coordination, approvals, prioritization, sequencing, right? And you have 3,500 people all coupled to one couch. And so like the whole practice of like microservices, platform engineering is we're trying to separate those concerns, right? To liberate independence of action.
Yeah. Let somebody else bring down the cushions.
Yeah, right. No, totally. Right. Which it creates so much value and it liberates people's ability to contribute. So I love the explanatory power of that because we can take that same metaphor, right? Amazon 2001, right? 3,000 people all coupled together. They went from being able to do hundreds of deployments per year, went down to tens of deployments per year, right? And so, what they do about that was the famous Jeff Bezos memo where thou shalt only communicate through APIs. And it was essentially chopping up that couch into small pieces so that they could work independently of each other. And so 10 years later, they're doing 136,000 deployments a day, right? Okay, love it. That's one way to that the couch can explain that. But I love the Amazon Prime Video example that came out 2 years ago that said they went from microservices back to a monolith and reduced the cost by 95%. And I love that because it's as if they chopped up the couches into two small pieces, right? Because now all the effort is around coordination and transport, right?
Yeah.
So by gluing it all back together, right, you reestablish locality and coherence, right? And so you're not copying files in and out of storage buckets, right? It's now just at hand. And so, sorry, just to answer your great question. So, under what conditions do you want kind of a centralized group of engineers versus where do you want it sort of more closely embedded, with users, business users, and so forth? It's like, well, it depends, right? But now we know what it depends on. Who needs to talk most closely to whom, and how important is that, right? And the more you need joint co-creation with high levels of uncertainty, right? That's going to push you towards decentralization. But is for things like maybe SAP for basic financial processes like accounts payable. Well, you probably want that centralized, right? Because those patterns are so well known. How does that resonate with your own beliefs?
Well, it's less about beliefs and more of just searching for the right sweet spot, as opposed to just be a pendulum swing of reactions. And I just observe marketing organizations getting fed up with internal IT, and then they go and hire an outside agency. Why? Because the outside agency has programmers, and they don't want to. And so some departments is just like, okay, I'm going to figure out how to get my own programmers. I don't think it's a rule of thumb for everybody, but it's a good way to just think and ask that question.
Hey, can I give you like one other example that I just found so startling? And so like we're all playing around with generative AI, and it's amazing. I haven't had this much fun in like decades. A friend of mine, Dr. Mick Kirsten, he wrote the book Project to Product, and we were having a conversation. He said something, and I stopped my tracks because it was so startling to me. And so basically, what he said was, they have something called like Plan View Copilot, right? The idea that and the notion was that he went from kind of a decentralized kind of group of Gen AI prompt engineering group to centralizing. And so why? It's because that he was alarmed that they're experimenting with moving some workloads from like using GPT-4 to Claude. But the problem was that the prompt engineering practices were so varied that they had inadvertently coupled themselves, to a specific frontier model, right? And so, which is a terrible place to be. Like when things are changing this quickly, you want to bring that switching cost down to zero, right? Right. So my question was, like the API shapes are the same. What do you mean? You can't switch from one to the other. And he said that the prompt engineering practices were so varied that basically it would be a heavy lift across basically every major product group. And so the goal was to actually re-centralize those functions so that, and have all the prompts live in one repo, right? So that you could have a group that was responsible for, potentially painlessly migrating from one frontier LLM to another. And so it's just interesting because all the symptoms sound very familiar. And yet, the way they manifest are very different, but it's all about coupling, right? And so even in the age of LLMs, right, where it's not about API compatibility, but it's about something else where you want sort of like the ability to have optionality to switch from one to the other. How am I doing?
Right. It's like coupling more on the people side than technology. It's how much people have to communicate and work together.
Right. And or like it's like the groups knew too much about the other side of the LLM interface, right? It's like, it's
right.
EP4 versus Claude 3, whatever.
Right. Your microservice example of going microservices and then come back to a monolith, that story is getting told over and over again with all these people that are going full on microservices and then realizing, oh no, okay, now we don't like something about it, and then they come back together. I mean, Microsoft did that with Azure DevOps and the mono repository pattern. But I wonder if If it's a different vector, that's the problem. The monolith, it's been around for a long time. We can't move fast with it. And we think, you know what? Separate Git repositories is the answer. Microservices. So let's split up where the code is stored, which forces us to have independent builds, independent tests, independent deployments, independent configuration, independent operations. It forces us to actually fix the problems that we wouldn't fix as a monolith. But then, of course, we don't like how expensive it is to run and some of these other problems. So we're like, you know what? Let's see if we can put it back together. But when it's put back together, because we've learned it, we're able to preserve the better build patterns, the better pull requests and branching and testing, and better, the logical boundaries that we've put in there. And now we have a monolith again, but it's actually a better architected monolith, and we're actually able to move fast and quickly because we actually learned how to do a good monolith.
Yeah, that resonates 100% to me, and it shows, so in our book we have this the notion that kind of the layer 3 systems must be isomorphic to layer 1 and layer 2, and so Conway's law is probably a part of that, right? Where what you just said is that by partitioning the Git repos, it forces and when certain microservice components can't talk to another, it forces a change in layers 1 and layer 2. Absolutely right. And what you just said is that you can do that without actually having to force specific code to live in different, say, containers, right? 100%. That absolutely resonates with me.
So perhaps the people who've gone through that journey and now know what a well-architected large system in a single Git repository can look like, the next system that they build from scratch, they'll put those things in place from the beginning, and then might end up with a one Git repository system where they can still do many deploys a day.
Yeah, that is totally consistent with my own observations and experiences. And by the way, I think maybe this actually we didn't put in the book, but Dr. Ron Westrom, he introduced me to this term of the socio-technical maestro. And he said these great leaders, they have these 5 characteristics. They're great. They have high energy, high standards, great in the large, great in the small, and they love walking the floor. And when I heard that, it just hit me like a ton of bricks. Like that's exactly resonates with my own experiences and how I assess how good of a leader is, right? And leaders at all layers is they have this sensibility of what are the conditions that allow people to do their work easily and well. And I think the language that gives us so many of the tools to describe it come from software architecture, right? It is really about to what degree, where are the logical boundaries, hard or soft, right?
Yeah.
And for the purpose of isolation, but also independence of action, right? To enable people to do their work without a lot of communication and coordination. And just to belabor the obvious, that was a finding that came out in 2017 in the State of Research, saying that one of the top predictors of performance was software architecture, and that was all Jez Humble's work, and that really taught me a lot about what good architecture looked like. But I got to tell you, working with Steve Spear, really trying to understand, I feel like I now finally understand what coupling and coherence really are all about. And it's not just about software architecture; it's about any system where you have multiple groups that need to work together.
Right. Well, this interview could go on for several more hours. I just want to encourage the listeners to read your latest book, Wiring a Winning Organization, and of course all the past ones as well. But as we kind of wrap up here, for people who want to dig in further and learn more in this area of organizational leadership, are there any final tips that you would impart them with?
Oh my gosh, yeah, I would say that working on this book was the most intellectually challenging thing I've ever worked on in my entire career, but also one of the most rewarding. I feel like I'm going to spend the rest of my career really understanding kind of what it means to use these principles and these mechanisms. And I guess I just continue to be blown away by how important the notion of independence of action is. In fact, we're running a conference that you had mentioned, the Enterprise Technology Leadership Summit at the end of August. And I would say a third to a half of the talks are about this, what the power that this creates. There's a talk from Vanguard about all the bad things that happen when you have these batch jobs that run and you can't stop, and they have this blast radius that potentially impacts everybody. Yeah. And what can be created when you can actually pause them or split them up by running them in like lambdas, that it too creates independence of action. It now allows certain categories of problems to be solved not by the engineering manager, but by the product manager, right? There's a talk from Austin Puckett from Clear about doing the same thing so that airport operations, lane managers can make decisions without having to be coupled to the engineering teams, right? And allowing people to make decisions close to the edge. I mean, it's so great. And so if you're interested in that, just go to look at Enterprise Technology Leadership Summit. And I just continue to learn and marvel at, just how important of a sensibility it is for it to have leaders understand, like, what does it take to wire their organizations well, and just to see how many dimensions of value they can create, not just for the technology team, but for the organizations they serve.
Amazing. Wow. That's a lot. That's great. That's great. Gene, thank you so much for coming on the Azure DevOps podcast and sharing your vast and long tenured experience wiring a winning software organization. I really appreciate the conversation.
Jeffrey, right back at you. Keep up the amazing work, and I very much look forward to meeting you in person one of these days.
Likewise. Thank you so much. And until next time, keep shipping.
You've been listening to the Azure DevOps Podcast, a show for developers and DevOps professionals shipping software using Microsoft technologies. Go to www.azuredevops.show for show notes and other episodes. On behalf of your host, Jeffrey Palermo, and our sponsors, thanks for listening, and may God bless you.